What is mathematics? Is it a toolbox? Is it a theory? Is it a mindset? Is it a science unto itself? There are elements of all of those things. And here we use math and many of its different levels of abstraction. In applied mathematics, there is a kind of descending order of abstraction, of taking away from the concrete things and going to a higher level sort of thought. Yes. So first and foremost, we have numbers, which we take for granted, but numbers are a big deal, right? It's not something that even many animals can't get numbers. There are birds that don't recognize if they have 5 or 6 eggs in their nest. You can take one away or add one, and they won't even notice. Um, so numbers are a big deal. It really is, and it's foundational to our application of mathematics, our applied mathematics. Um, And I bring this up in particular because we need to think about the precision of numbers and how they relate to the reality of things. And this brings in units of measure and systems of measurements and tools for making these measurements. So it's a vast system just for numbers, All right. Um, Next, we come to arithmetic, which is working with those numbers. Arithmetic is the using addition, subtraction, multiplication, division, uh, exponents, which is an extrapolation of multiplication, using roots and um, all these sorts of things to do things with our numbers. Yes, the trigonometric ratios could actually be considered arithmetic in a sense. Though to use them in most of their strength, you're going to be looking at more like functions, which is coming later. The next order of abstraction would be algebra. Algebra is the use of letters to hold the place of numbers so as to allow you to do some more advanced forms of arithmetic that we wouldn't necessarily be able to see in our heads. All right, there's some algebraic uh, operations and so forth which go well beyond what most people could keep track of in their head. So it allows you to let the paper keep track of a great deal of your work with your numbers and still arrive at an answer. It can also give you some general answers, say if it relates two different numbers to each other, for instance. So that's very, very valuable. The next step after that in our increasing abstraction is functions, and that could be thought of as a subset of algebra, because here we have that idea of relating two or more variables to each other with specific rules really coming into its own. That's what functions are all about. They are rules for taking one input and giving you a discrete output. Okay? And we can use functions to model so many things in the real world. So the next order of abstraction is calculus, where you take functions and you look at how they change over time. So you can look at the exact rate at which one variable is changing with respect to another, for instance, or you can find the area under a curve. That is to say, the function mapped on a Cartesian plane can have a very strange shape. Well, with calculus, you can find the area under that curve. And this acts as a sort of guide or rubric for our study of mathematics here. The numbers and arithmetic and some of the algebra are pretty much used everywhere here at Optimax. And then more advanced forms of algebra and calculus are used by engineers and so forth as they deal with you know, advanced computer models, computer programming, etc.